Hi, welcome back. This is Professor Ridge, and today's lesson is on section 7.2, the circle and the ellipse. Okay, so this is review from section 1.1, standard equation of circle, with center hk and radius r is x minus h squared plus the quantity y minus k squared equals r squared. Okay, so again, go back to 1.1, you can see we use the distance formula to come up with that equation. And a circle is a conic section. So if you were to take the cone and slice it where it's perpendicular to the center line of the cone, you'll get a circle. Okay, so find the center, the radius, and the radius of the circle, then draw the graph. Okay, so our first step is going to put it in standard form. So we're going to put the x squared plus 6x together, leave a blank, plus y squared minus 2y, leave some space, equals 6, and we're going to complete the square. Okay, so we're going to take half the middle term. 6 divided by 2 is 3. 3 squared is 9, and add it to both sides. Same thing for y. Half the middle term is negative 1. Negative 1 squared is 1. 1, add it to both sides. And then we're going to combine 6 plus 9 plus 1 is 16. So now we know that the center is negative 3, 1. And remember, hk, you got to switch the signs. This is plus 3, so we make minus 3. And that's minus 1, so it's plus 1. And then the radius is 16, so r equals 4. So we got the center, the radius, and now we're going to graph it. Okay, so we start with the center, negative 3. Negative 3, 1 would be right there. And then from there we measure my little compass here. I measure 4 units. And then we draw it. Compass not working, hang on. Okay, so again, you set your compass. Don't have, my compass just broke, so I'll just do best I can. I just measured out some points. Alright, there you go. So you set the center, negative 3, 0, you set your compass 4 units away, and then just twist it around and make a circle. Pretty straightforward. Okay, so an ellipse. An ellipse is a set of all points in a plane, the sum of whose distances from two fixed points, which we call the foci, or foci, is constant. So some people say foci, some say foci. I go back and forth. Alright, the center of an ellipse is the midpoint of the segment between the foci. Okay, so the standard equation of an ellipse with center at the origin, and its a major axis is horizontal, and we'll talk about what that is in a second. So you got x squared over a squared plus y squared over b squared equals 1, provided a is greater than b, which is greater than 0. So a and b are positives, and a is bigger than b. Okay? And so basically what we're going to get, here, hang on. Okay, so what's going to happen is center is 0, 0. Your focus, or foci, plural for focus, is going to be C 0, and negative C, 0. Your vertices, that's plural for vertex, is going to be A0 and negative A0. And then the y-intercepts be 0b and 0 negative b. Now note C, a squared minus b squared equals c squared. So you solve that for C to figure out where the focus is, or the foci are. And I'll show you an example in a minute. Now the major axis is, notice that when you do an ellipse, it's kind of this, it's not a circle, it's kind of elongated. So the major axis is from A0 to negative A0. That's the major axis from there, connecting those 2 points. And then the minor axis, this is the minor axis. And then the major axis is connecting from negative A to A. Oops, to there. That's the major axis. Okay, so it's the bigger one. Minor would be the smaller one. Alright, so if we have the major axis is vertical, so basically A is still the bigger number, and see that A is going to be under the y squared. That's how you know if it's vertical or horizontal. It's wherever the bigger number is under. So if the bigger number is under y, y is vertical, so it's a vertical major axis. And let's see, your center will be at 0, 0. Your vertices will be, now the major axis, the vertices are always on the major axis. That's something to remember. So we're going to go A in the y direction. So it'll be 0A and 0 negative A. Foci, or y-intercepts, no, these will be x-intercepts, sorry, will be B0 and negative B0. And then the foci will be, again, the foci are also on the major axis, so that's vertical major axis, so we're going to add and subtract C for the y coordinate. So it'll be 0 C and 0 negative C. And of course, same thing as from above, where A squared minus B squared equals C squared. Alright, let's try to graph a couple of these and see how it goes. Okay, so find the vertices and the foci of the ellipse, and then graph. Alright, so my first thing is I notice, alright, the bigger number is 25, so this is going to be a horizontal major axis. And A is going to be A squared equals 25, so that tells me A equals 5. And B squared equals 16, so that tells me that B equals 4. And then I know that C squared equals A squared minus 25, minus B squared. So that's 25 minus 16, which is 9. So that tells me that C is 3. So C is 3, A is 5, B is 4. Alright, so now I know that the center is 0, 0. the vertices, remember, vertices are always on the major axis. So if the major axis is horizontal, you're going to add A to the x-coordinate of the center. Add and subtract it. So it's going to be 5, 0, and negative 5, 0. And the foci, same thing. I'm going to add and subtract B to the x-coordinate because it's a horizontal major axis. So I'm going to go 4, 0, and negative 4, 0. And you're adding it to the center. So if the center was 3, 2, which we'll do in a minute, you're going to add 4 to the 3, and you get 7, 2. Alright, let's graph this thing. Oh, I messed up. Foci is C0, so that should be C0, so that should be 3, 0, and negative 3, 0. Okay, now let's graph this. Alright, so we got the center 0, 0. Now from the center, I'm going to, so basically the way I do this is I kind of look, I don't actually figure out the center and all that stuff. Well, I always figure out center first, and then I look, okay, under the x, square root of 25 is 5. So in the x direction, I go 1, 2, 3, 4, 5, put a dot there. And then I go back to the center and go 1, 2, 3, 4, 5 in the negative direction. Put a dot there. And then I go, okay, in the y direction, square root of 16 is 4, so I go up 4, down 4. And then I don't even need to plot the foci to do the ellipse. I just make the best oval I can. Oops. Make the best oval I can. You know, I always get more eggy looking things than a nice ellipse, but this is just a rough sketch. So just do your best. And then if I need to label the foci, it's at 3, 0, and negative 3, 0. So there's negative 3, 0, 3, 0. And so the vertices at 5, 0, negative 5, 0, foci, negative 3, 0, 3, 0. Alright, and that's it. That's all there is to it. So graphing's pretty easy. Let's try another one. Okay, so same thing. Find the vertices, foci, and the ellipse, and then graph. Now this one's not in standard form, so your first step is you gotta, the idea is you want to get a 1 there. So our first thing is we're going to divide everything by 144 to make that a 1. So 16 into 144 is 9. 9 into 144 is 16. We're just canceling. 144 divided by 144 is 1. Now we're ready to go. Let me graph it first, and then we'll write down the vertices and all that. Okay, so the center is 0, 0. And then again, I'm going to look under the x is 9. Square root of 9 is 3. So I'm going to go 1, 2, 3 in the x direction. 1, 2, 3, negative 3 in the x direction. Then I look under the y, 16. Square root of 16 is 4. So then I'm going to go 1, 2, 3, 4 in the y direction. 1, 2, 3, 4. And I'm counting from the center. And then I just connect these 4 dots to make my nice oval. Just kind of go out like that. Just do your best. It'll probably be kind of eggy on the test, but that's okay. There's little tools to make a nice ellipse curve, or you can use a piece of string and locate the foci and then do it, but we won't do that. Alright, and that's it. So now we just need to identify the vertices. Now again, the vertices are on the major axis, so you notice 16 is on the y, that's the bigger one. So we're going to add and subtract 4 to the y coordinate. So it's 0, 4, 0, negative 4. So that's vertice. That's one vertex. That's one vertex. Plural is vertices. And then the foci. So first, we got to figure out what C is, and then we can write the foci. So we know that C squared equals B squared minus A squared, or A squared minus B squared. So that's 16 minus 9, which is 7. So C is square root of 7. So it's going to be 0 square root of 7, comma, 0 negative square root of 7. And then to graph that, square root of 7 is 2.645, so 2.6 roughly right there. So that's 0 square root of 7. And again, it's always on the major axis. There's negative 2.7, 2.6. Okay, so now let's talk about moving the center. Okay, so it's exactly what you would expect with the transformations. You're just going to go x minus h in parentheses squared over a squared plus y minus k in parentheses squared over b squared equals 1. And then we just make all our appropriate changes. So the vertices now, so what I was saying earlier is, right, when you do the plus a minus a, you're doing it along the major axis from the center. So if the center is 0, 0, you're going to go a 0 and negative a 0. But now we moved the center to hk, so the vertices is going to be h plus a, k, and h minus a, comma, k. Okay? And then our foci is going to be h plus a, c, c's for the focus, k, and h minus c, k, comma, k. And then the length of the minor axis is going to be equal to 2b. Alright, so you're just going to add b, you're going to go from the center, you're going to go up b and then down b, so that length is going to be 2b. Okay, so if we find our center at hk, then we're going to go a units this way, so that'll be a vertex, h plus a, k, and then you're going to go a units back, so that'll be h minus a, k, and then in the y direction I'm going to go up b, down b, so that's length of that minor axis will be twice b, and then you just connect, make your oval. Same idea. I guess I should have wrote that somewhere else. Okay. So that's the idea. And then if we do the major axis is vertical, same thing, but the A is going to be under the Y. Okay, but then with the vertices, now since the major axis is vertical, we're going to add and subtract A to the K coordinate of the center, the Y coordinate of the center, which is K. So it's K plus A and H, K minus A. And then for the foci, same thing. We're going to get h, k plus c, and h, k minus c. And we still get c by doing c squared is b squared minus a squared. I forgot to write that up here. So, same thing. No, c squared is a squared minus b squared. I wrote this one backwards. C squared is a squared minus b squared. Okay, you do the bigger one minus the smaller one. And then the length of the minor axis is still going to be 2b. Okay, so again, you find the center hk, and then you're going to go up a. That's the square root of the number under the y coordinate. And then you're going to go down a, so it'll be k minus a. Then you're going to figure out what b is, and you go to the right b from the center. So that's going to be h plus b, okay. Then you go to the left, b units. That'll be h minus b, okay. And then the focus is going to be, you're going to go up c, down c. It'll be something like that. Okay. All right, let's graph a couple of these, see how we do. Okay, so again, I always start with my center, which is going to be equal to, you're going to change the x coordinate, so that'll be 3. Change the y coordinate, -2. Then I make my graph. Okay, so center's 3, -2, right here. And just like we did with the transformation, I'm going to pretend that's the origin. And then again, I'm going to look under the x is 9. So square root of 9 is 3. So I do plus 3 minus 3 in the x direction. So from here, I'm going to go 1, 2, 3, put a dot. And then -1, -2, -3 in the x direction. Then I look under the y. Square root of 25 is 5. So in the y direction, I go up 5, down 5. 1, 2, 3, 4, 5. And then I make my oval. And I just do the best attempt at making an oval. So we're just doing a rough sketch. That's usually all I'll have you do on the test, is give me a sketch like that. And then now let's answer the vertices. And then you notice where's the bigger number? Under y. So we're going to add and subtract 5 to the y coordinate for the center. We want to know what that point is. So if I go up 5, it's 3, -2 plus 5, which is 3, 3, which I can just read it off my graph too. That's the other thing. And then when we go minus 5, that's 3, -2, minus 5. So that would be 3, -7. And then the foci, we got to figure out, well, what's c? So if you note, c squared is 25 minus 9, which is 16, so c is 4. So we're going to add, subtract 4. Here's the foci on the y coordinate. So the foci would be 3, -2 plus 4, and 3, -2 minus 4, which equals, of course, 3, 2, and 3, -6. So there's the foci, vertices, center, in the graph. Okay, let's look at one where you have to complete the square. So we're going to do, what you do is put the 9x squared plus 54x plus 4y squared minus 8y. We'll put the 49 on the other side, so it becomes negative 49. Now what you have to do is factor out the coefficient of the squares from the square term and then its linear term. So I'm going to factor out a 9 from x squared, 9x squared. Factor out the 9 from 54x. So you divide. And what you do is put a plus blank minus blank close parenthesis. Now we're going to factor out that 4 from the y squared and the y term. So we get y squared minus 2y plus blank minus blank equals negative 49. Now this is a variation of the completing square technique. Instead of adding a number to both sides, you're going to add it, subtract it. You're going to add it and then immediately subtract it, and you get 0. And the reason you're going to do that is because you're inside these parentheses, so you can't add it to both sides. I mean, you could if you knew the adjustment to make, but let me show you what you do. So let's add an extra step here. So now I'm going to complete the square. Half the middle term is 3. 3 squared is 9. So I add it, subtract it. So divide, square. Divide by 2 is 3. 3 squared is 9. Add it, subtract it. Now these three terms, x squared plus 6x plus 9, is equal to the x plus 3 squared. And then you got this minus 9 left over. They do the same thing with the 4. The y squared. So y minus 1. 1 squared is 1. Add it, subtract it. Again, the three terms is the parentheses squared. Then you got the minus 1 left over. Now what you need to do is you distribute the 9 into the bracket, and you get 9 times x plus 3 squared minus 9 times 9 is 81. Because you got to distribute that. Same thing with the 4. So you're going to go 9 times the parenthesis. So we're not actually going to multiply it out. We'll just write it in front of the parenthesis. Then 4 times negative 1 is negative 4. And now from here you're going to add 81 to both sides. Add 4 to both sides. And you get 9x plus 3 squared plus 4 y minus 1 squared equals, let's see, 36. And then of course now your next step is you're going to divide everything by 36 each term. So you get 1 equals x plus 3 squared over 4 y minus 1 squared over 9. Okay, and then now we're ready to graph. Well, first we'll find the center. Okay, so our center is negative 3, 1. And A is, let's see, the major axis is y. So A is 3. We'll do plus 3 minus 3 for the y coordinate. So that's going to get us negative 3, 4, and negative 3, negative 2. And then we got to figure out the foci. So c squared is 9 minus 4. And then you got square root both sides. So c is square root of 5. And then again, major axis is the y, so I'm going to add and subtract the 5 to the y coordinate. And 1 plus square root of 5 and 1 minus square root of 5, that's as simple as you can write it, so just leave it like that. Alright, so let's graph this thing. The center, -3, 1. Okay, so the center is -3, 1. Under the x, square root of 4 is 2, so I go +2, -2. Under the y is 3. It's 9. Square root of 9 is 3, so I go 1, 2, 3. 1, 2, 3. And then I make my best attempt at an oval. And there you go. And then the foci, let's see, square root of 5 is 2.23. So 2.23, right about there. 2.23, right about there. Okay, so that's your foci. Okay, let's do one more example. It says find an equation of ellipse satisfying the given conditions. So, first of all, we notice that the center is the midpoint between these 2 points. So if you did the midpoint, so center is the midpoint between the vertices. And the foci too, also. Or and, I guess and. So you only need, if you're given either the vertices or the foci, you don't have to be given both. If you're given one of them, you can figure out what the center is. Okay, so just use the midpoint. So the center is going to be equal to -7 plus 7 over 2, and 0 plus 0 over 2, which is 0, 0. Okay, so that makes it easy. So we know the standard form is going to be this. And we know that since the x-coordinate is the one that's changing, we know that the vertices are in the horizontal direction, so A is going to be under the x. So A is equal to 7, because from 0 to 7 is 7. That's the distance from the center to a vertex is A. Right, distance from center to a vertex. So we're going to get x squared over 7 squared is 49. Now we just, oops, that should be 0, that should be 1. So now we got to figure out what B is, and we don't know, they don't give us B, but they give us C, and we know A. We know that C squared is A squared minus B squared. So C squared is 3 squared, A squared, 7 squared minus B squared. Now we just solved that. 9 equals 49 minus B squared. We're going to subtract 49, so 40 negative B squared, divide by -1. Now the idea is we're just looking for B squared. We don't necessarily need to know what B is. I mean, you could. So B squared equals 40 b is square root of 40, but the number that I'm going to put here is b squared, which is 40. So I don't need to square root it and then square it again. Just wasting my time. But if you want to, you can go ahead. So there's your answer. X squared over 49 plus y squared over 40 equals 1. Alright, so that concludes the lesson for 7.2. Go to My Math Lab, complete your exercises there, and I'll see you next time.